Good day everyone, you are welcome back to mathematics class. Today we are going to look at matrices and simultaneous equation. Alright, so here we are going to be using matrices to solve a pairs of given simultaneous equation. Alright, so let's dive in. Now the question we are going to be solving are what you are seeing on the screen. So we have 4 questions here. And the question says solve the pairs of simultaneous equations using matrix method. So how do we use matrix method to solve simultaneous equation? That is exactly what I'm going to show you in this video. Just follow. Alright, so let's begin by taking this first example. So we want to solve this pair of simultaneous equation using matrix method. Solution. So the first thing you do here is to write the matrix expression of this simultaneous equation. Now how do we do that? You see, the coefficient of x in, let's assume this is our equation 1, all right, and this is equation 2. All right, so from the equation 1, the coefficient of x, I'm going to write it first, 6. Then the coefficient of y in equation 1 as well, that is plus 11. Then the coefficient of x in equation 2, I will write it to form the second row, which is 1. The coefficient of x in equation 2 is 1. Then the coefficient of y in equation 2 is plus 2. Alright. Then I'm going to multiply this matrix now by the variables. What are the variables we have in this simultaneous equation? We are having x and y. Okay, then equal to what I'm having at the other side of the equation in the simultaneous equation, and we have 29 and 5. All right, so this is the matrix expression of the simultaneous equation given to us. So I think you now understood how to write expressions, matrix expression from the given simultaneous equation. Now after this, the next thing to do is to divide both sides by this matrix. Okay, you see this matrix that I circled, you are going to divide both sides by it. And how do we do that? So I will just write, when you divide both sides by that, you have your x then and y to be equal to, then you have 6, 11, 1 and 2. So when it comes to this other side, it changes to inverse. Okay, inverse, because we have learned that when you have a matrix A, so the inverse of this matrix A is written as A raised to power minus 1. Is that understood? Okay, so that is exactly what we are having here. Then I will multiply it with what we have left, which is 29 and 5. Okay, so hope you are following. The next thing to do is to find the inverse of this matrix. Okay, so let me just write but 6, 1, 11, 2 raised to power minus 1 is given us. So this is what we call inverse of matrix. Now you still remember how to find the inverse of matrix. If not, you can go to the previous videos that I made on inverse of matrix and then go through it. Now let's quickly find the inverse of this matrix. We have here 1 divided by determinant of this matrix. Okay, so what is the determinant of this matrix? The determinant is 6 multiplied by 2, that is 12. Then minus, let me just write it here first, 12 minus, then I will multiply 11 and 1 together. 11 times 1 is 11, then minus 11. So 12 minus 11 will give me 1. So the determinant is 1. All right, so I am doing it this way because we have learned it before. Understood? So let's go ahead. Then multiplied by, then I'm going to change this. Okay, I'm going to interchange these numbers diagonally. So that is where 6 is, I'll put 2 there. Where 2 is, I'll put 6 there. Okay, and then this 11 and 1, I will change their sign from positive to negative. If you remember, that's what we did in our previous class. Okay, so here we have 2. This one will become minus 11. Here I will have a minus 1, and here I will have 6. Okay, so 1 divided by 1 is still 1. Then 1 times the whole of this will still give us the whole of that. Is that understood? Okay, so having done that, let me just write it here that it will be finally equal to 2 minus 11 minus 1 and 6. Okay, so we are going to substitute this now into this. Okay, so let's quickly do that. Let me put a line here. So now we have x, y equal to, so the whole of this now has changed to this. Is that okay? So that's the whole essence. So I'm going to replace that with 2 minus 11, then minus 1 and 6. All right, then multiply by this. Okay, which is 29 and 5. Okay, so we now write x and y is equal to, now we are going to multiply these two matrices together. So we have learned how to multiply matrices together. If you've forgotten that, you can watch the previous videos and then come back to continue learning this. Okay, so let's continue. So we are going to use this rule to multiply this column. That is how we rule in multiplication of matrices. So we have 2 times 29, then plus minus 11 times 5. Okay, then the second rule will be minus 1 times 29, then plus 6 times 5. Okay, all right, so we now have x and y to be equal to 2 times 29 will give us 58. Then plus times minus is minus. 11 times 5 is 55. Then minus 1 times 29 will give us minus 29. Then plus 6 times 5, that is 30. Okay, so we have x, y to be equal to 58 minus 55 is 3. And minus 29 plus 30, that is 1. Okay, so as you can see, our x now is equal to 3 and y is equal to 1. So this is how to use matrices to solve simultaneous equation. Well, I'm going to take another example for you to understand it better. All right, so let's continue. Now this is another question. We have these two pairs of simultaneous equation, and we want to use matrices to solve them. So we have solution. So the first thing to do now is to write the matrices expression for this simultaneous equation. So the coefficient of x in equation 1, this is equation 1, this is equation 2. So the coefficient of x in equation 1 is 4, and the coefficient of x in equation 2 is 1. The coefficient of y in equation 1 is minus 2, and the coefficient of y in equation 2 is plus 1. Okay, then I'm going to multiply it with the variable, which is x and y, then equal to 9 and 3. Okay, all right, so x and y will be equal to the inverse of this matrix here. Okay, this matrix, that's why I'm going to write it right here now. So the inverse will be 4 minus 2 1 1, then everything raised to power minus 1. So that is inverse. Okay, then multiply by 9 and 3. Okay, all right, but 4 minus 2 1 1, so its inverse will be equal to, just like we have learned how to find the inverse of matrix. Don't forget the formula is 1 over determinant of this matrix. What is the determinant of this matrix? So we have 4 times 1, multiply it diagonally. 4 times 1 is 4, then minus 1 times minus 2, which is minus 2. Then we have 4 minus 2, and 4 minus minus 2, that will be 4 plus 2, and that is 6. Okay, then multiply by, I'm going to exchange this 4 and 1 diagonally, then change the sign of these other two elements. All right, so I will now have a 1, 2, minus 1, and 4. So you have learned this before. If you are still confused with how to find the inverse of matrix, please go and watch the video on inverse of matrix. Understood? So we will now write that x and y will be equal to, so the whole of this now has changed to this. Is that understood? So let's quickly slot that in. We have 1 over 6, then multiply by 1, 2, minus 1, and 4. Okay, then multiply by 9 and 3. Okay, so let me divide this. Okay, so we continue. We now have x and y to be equal to 1 over 6. Then we are going to multiply these two matrices together. Okay, just like we did in the previous example. Now when you multiply that, you are going to have 1 times 9 is 9. Okay, then plus 2 times 3 is 6. All right, so we have minus 1 times 9 is minus 9, then 4 times 3 is 12. Okay, so x and y is equal to 1 over 6. Now 9 plus 6, that will give us a 15, and minus 9 plus 12 will give us a 3. Okay, then equal to, so multiply everything inside the bracket with 1 over 6 outside. So 1 over 6 times 15 is 15 over 6, and then 1 over 6 times 3 is 3 over 6. Okay, so this is 6. All right, that is our x and then y. But we can still simplify this further to give us x and y to be equal to, now 3 goes in 15, that is 5 times. 3 goes in 6, that is 2 times. 3 goes in 3 1 time. 3 goes in 6 2 times. So we now have a 5 over 2 and a 1 over 2 left. Okay, so if we continue here, we can now write that x and y is equal to 5 over 2 can be written as 2 whole number 1 over 2, then this is 1 over 2. So now let's conclude and say therefore x is equal to 2 whole number 1 over 2, and y is equal to 1 over 2. And that is how to solve this simultaneous equation using matrix method. Understood? All right, so I want you to also take your time to solve these two questions using matrix method to solve these two simultaneous equations. It's very simple. All right, now let's take a look at this example again, and we are going to use we are going to use matrices method to solve this simultaneous equation. Okay, solution. So let's write this simultaneous equation in matrix expression. So we have x 7x, so, and then 4y. So write the coefficient of x in equation 2, 4. The coefficient of y in equation 2 is 2. Okay, so everything multiplied by the variables x and y, then equal to 29 and 16. Okay, so as usual, x and y will be equal to the inverse of this coefficient of x and y, which is 7, 4, 4, 2, everything raised to power -1, then multiply by 29 and 16. Okay, but let's quickly find the 7 for the inverse of this matrix. Okay, so what would the inverse of this matrix be? That would be 1 over the determinant of this matrix. And what is the determinant of this matrix? We have 7 times 4, that is 7 times 2, that is 14, minus 4 times 4 16. So 14 minus 16, that is -2. That's the determinant. Then we multiply this with the exchange of these matrices. This 7 and 2 will interchange, so I will have 2 here. Then this 4 will change to -4. This other 4 will also change to -4, and this 2 becomes 7. Okay, you have learned this over time. You should have know it by now. All right, so let's continue from here. So let's continue. We now have x and y to be equal to, now we've already found the inverse of this matrix, and we are going to replace it with 1 over -2, then times 2 minus 4, and -4, 7. Okay, then multiply by 29, 16. All right, so let's quickly multiply this together. So multiply these two matrices. We'll have 2 times 29. Let me write it out. 2 times 29, then plus -4 times 16. Okay, then we have -4 times 29 plus 7 times 16. Understood. So let's continue. Now let's multiply this together. 2 times 29 is 58. Then plus times minus is -4 times 16 is 64. Then -4 times 29 is -116. Then plus 7 times 16 is 112. Okay. Alright, so 1 over -2. 58 minus 64 is -6. Then 1 minus 116 plus 12, that is a -4. Okay, if you multiply this, we now have 1 divided by -2 times -6. Minus times minus will give us plus. Then we have 6 over 2. Okay, then 1 over -2 times -4, minus times minus will change to plus. Then we have 4 over 2 left. Understood? And then let's continue here. We can now write and see x, y is equal to, 6 divided by 2 will give us 3, and then 4 divided by 2 will give us 2. And we conclude and say x is equal to 3 and y is equal to 2. Okay, so finally let's solve this. We want to solve these pairs of simultaneous equation using matrix method. Solution. Now what we do first here is to write this simultaneous equation in matrix form. And how do we do that? Look at equation 1 and equation 2 here. The coefficient of x in equation 1 is 1, and the coefficient of y in equation 1 is -3. Then the coefficient of x in equation 2 is 2, and the coefficient of y in equation 2 is +4. Alright, so multiplied by the variables which are x and y, then equate it to 2 and -1. So we have write the expression now in matrix form. Okay, so as usual, our x and the y will be equal to the inverse of this matrix, that is the coefficient of x and y here, okay, multiplied by 2 minus 1. All right, so x, before we even write x, now let's find the inverse of this matrix. Okay, now to find the inverse, we write 1 minus 3, 2 and 4. Okay, raised to power minus 1 is equal to 1 over determinant of this matrix. 1 times 4 is 4, then minus 2 times minus 3 is minus 6. So that is 4 minus minus 6. Okay, multiply by, I'm going to change this 1 over 4. I will interchange them, and then these ones, I will change their signs. This minus 3 will change to plus 3. Y 2 will change to minus 2. Alright, so writing that, I have 4, 3, minus 2, and 1. Alright, so that's the inverse of that matrix. So we'll continue the equation from here. Okay, so we now have x, y, then is equal to, that inverse is 1 over 10, multiplied by 4, 3, minus 2, and 1. Then multiply by 2 and minus 1. Alright, so let's multiply these matrices together. Okay, so when we multiply them together, we have 4 times 2, that is 8, plus 3 times minus 1, that would be minus 3. Okay, then we have minus 2 times, so we have minus 2 times 2, minus 2 times 2 is minus 4, then 1 times minus 1 is minus 1 plus minus 1. Okay, alright, so we now have x and y to be equal to 1 over 10. Then 8 plus minus 3, that is plus times minus is minus. 8 minus 3 will give us 5. Then minus 4 plus minus 1, minus times minus is minus. Minus 4 minus 1 will give us minus 5. Okay, so we have x and y to be equal to, now 1 over 10 times 5, we have 5 over 10. Then 1 over 10 times minus 5 will give us minus 5 over 10. Okay, so finally here we write x, y to be equal to 5 goes in 5 one time, 5 in 10, that would be 2. So we have 1 over 2, and here also we have 1 over 2, but this time around is minus 1 over 2. Okay, so we can now finally say is x is equal to 1 over 2 and y is equal to minus 1 over 2. Alright class, so this is where we are going to end today's class, and please take your time to go through this video again. This is how to solve simultaneous equation using matrices. Alright, so thank you for watching. God bless you. If you are yet to subscribe to this YouTube channel, kindly hit the subscription button now, like this video, comment and share so that it can reach others. Thank you for watching. Bye.